Welcome to Mickey Study Circle channel. In this video, we shall see how to understand the orthographic projections using the two reference planes, that is the vertical plane and the horizontal plane. So as you can see here in the window, there are two planes. Vertical plane, so we can consider this reference plane as a plane which is perpendicular to the ground. So this is the vertical plane which is perpendicular to the ground. And we have got one more reference plane called as the horizontal plane, and this plane is considered to be parallel to the ground. So we are going to understand the four quadrants using these two planes, that is the vertical plane and the horizontal plane. As we can see, the vertical plane and the horizontal plane is intersected at the region called as the XY line or the reference line. So this reference line marks the intersection of the vertical plane with the horizontal plane. So this XY line is now going to divide this particular quadrant into four numbers, and each quadrant has its own namings, and we'll just understand what they are. So now coming to the first quadrant. So as you can see in the first quadrant, we have got the object located above the horizontal plane and is in front of the vertical plane. So this is how the first quadrant is nomenclated. Next comes the second quadrant. So the observer is here and he is seeing an object which is behind the vertical plane and then above the horizontal plane. So that is how the object is located in the second quadrant. Next, the observer is here and he is looking at the object which is there in the third quadrant. So he can just notice the object which is behind the vertical plane and below the horizontal plane. So this is how I can nomenclate the third quadrant, that is below the HP and beyond the VP, where HP stands for the horizontal plane and VP stands for the vertical plane. So next, the observer is here and is looking at an object which is here in the fourth quadrant. So it is nothing but it is in front of this vertical plane and it is below the horizontal plane. So this is how we can understand the nomenclature of the four quadrants and the object located in the four quadrants. So the observer is not going to change his position. So he is going to look at the object from a stationary position but in multiple quadrants. Now, the next concept is how to draw the multiple views of this object in each of the quadrants. So as we can understand that the vertical plane is perpendicular to the ground and the horizontal plane is parallel to the ground. So if you just imagine the first quadrant like this, we can just imagine that the vertical plane is this and the horizontal plane is something which is extruding away from the sheet. So in order to understand or have a clarity between the multiple views of the same object, we can just convert this pictorial representation into the orthographic projection. So the word orthographic here means the planes are aligned at 90 degrees to each other. So this is the first alignment. As you can see that the vertical plane is held perpendicular to the ground and the horizontal plane is held parallel to the ground. So in the orthographic projection, we are going to consider the horizontal plane only and then rotate this horizontal plane in the 90 degrees clockwise direction as shown here, indicated by the arrow marks. So when I do that, I am getting the horizontal plane below the vertical plane, and the XY line is going to differentiate the two reference planes, that is vertical plane and the horizontal plane. So now I can just understand that the vertical plane is above the XY line and the horizontal plane is below the XY line. So in all the cases, the front view of the object is recorded on the vertical plane and the top view of the object is recorded on the horizontal plane. So whenever we have got an object situated in the first quadrant, the object front view is recorded above the XY line and its top view is recorded in the horizontal plane, that is below the XY line. So this marks the views of the object in the first quadrant, which is also nomenclated as above HP and in front of VP. So this is about the object in the first quadrant. Now let us take up the case wherein there is an object located in the second quadrant. So the second quadrant, the observer is still here, is not anywhere else, is still here only, but the object is now there in the second quadrant. So now what has happened? There is a reference plane which has come in between the observer and the object. So this is the first case that has to be kept in mind. Also, the object is behind VP and above the HP. So as per our rule, the vertical plane will be held constant and the horizontal plane will be given a 90 degrees clockwise rotation. So as you can see, this is the XY line, which is the point of intersection of the vertical plane and the horizontal plane. So now this horizontal plane is rotated in 90 degrees direction in the clockwise direction. So now what happens? So whenever I'm rotating the horizontal plane, what happens? It is going to overlap on the vertical plane. So now what happens? The front views and the top views of the object that was there in the second quadrant is overlapped, and they are not being visible distinctively as in case of the first quadrant. So this is the problem with the second quadrant. So the object is lying behind the vertical plane, and the horizontal plane is overlapped on the vertical plane, and the top and the front views of the objects are not visible distinctively. But whereas in the first quadrant, since the horizontal plane is going to align itself exactly below the vertical plane in the 90 degrees direction like this, so the horizontal plane is showing the top view separately and the vertical plane is recording the front view separately. So for the observer to record the multiple views, the front view and the top view are recorded separately and it is visible distinctively. So I can choose the first quadrant for engineering drawings. Whereas in case of the second quadrant, as the horizontal plane is overlapping on the vertical plane, the drawings will not be visible distinctively, and hence it is not preferable to make any engineering drawings in the second quadrant. Now we will take up the case of the object in the third quadrant. So the observer is still here and there is a object which is behind this vertical plane and below the horizontal plane. So how do we understand here? So the concept is the vertical plane is kept constant and the horizontal plane is given a clockwise 90-degree rotation. So now what happens? The vertical plane, so this part is the vertical plane and this part is the horizontal plane, which is rotated 90 degrees in the clockwise direction. So we can just understand that the XY line is the one which is going to intersect the vertical plane with the horizontal plane. So now keeping this as the reference point, we can just understand that the horizontal plane has been rotated 90 degrees in the clockwise direction. So we can just edit the arrow marks. So we'll just see how the clockwise rotation is going to be done. So we'll just consider the arc by center point and we'll just ensure that we're going to show the rotation like this. So this is the clockwise rotation for the horizontal plane in the 90 degrees angle. So this is 90 degrees and it is going to go above the XY line. So now what happens? The vertical plane which is recording the front view is situated below the XY line and the horizontal plane which is recording the top view is gone above the XY line. So in case of the third quadrant, I've got the two planes distinctively recording the vertical and the horizontal plane, which is distinctively recording the front and the top views. So what happens? The top view is recorded above the XY line and the front view is recorded below the XY line in case of the third quadrant. So the third quadrant, which is also nomenclated as below HP and behind VP, is recording the multiple views in a distinctive manner. That is, they are visible clearly. Hence, I can select the third quadrant also for making my engineering drawings. That is, the front view recorded below the XY line and the top view recorded above the XY line, as the horizontal plane is going to get located exactly above the vertical plane. So this is the third quadrant. So now what we understand here is the third quadrant is exactly opposite to that of the first quadrant. That is, the front view is above the XY line in case of the first quadrant, whereas it is below the XY line in case of the third quadrant, and the top view is recorded on the horizontal plane below the XY line, and here the top view is recorded above the XY line on the horizontal plane. So it is exactly the vice versa of the first quadrant. So now we can understand how the first quadrant, second quadrant and the third quadrant are going to record the multiple views. Now let us come to the fourth quadrant. So the observer is here and there is an object in the fourth quadrant. So the fourth quadrant can also be nomenclated as below the horizontal plane and in front of the vertical plane. So now what happens if I'm going to rotate the horizontal plane keeping the vertical plane constant, the horizontal plane is simply going to overlap on the vertical plane. So again, what happens? Both the planes, that is the horizontal plane and the vertical planes, are exactly below the xy line, and hence I cannot distinctively see the multiple views of the object. That is, the front view and the top view of the object cannot be recorded on the separate planes because both the planes are overlapped on each other. So this is the problem with the fourth quadrant as well as the second quadrant, and hence we do not prefer the second quadrant and the fourth quadrant to make any engineering drawings as the views are not distinctively visible. And we can go ahead with only the first quadrant and the third quadrant because the multiple views of the object, that is the front view and the top views, are visible distinctively, that is above the xy line and below the xy line for the observer. So hence we are going to prefer only the first quadrant and third quadrant for doing the engineering drawings, and the usage of second quadrant and the fourth quadrant is completely ruled out in making any engineering drawings. So with this we end the video wherein we have understood the views of an object in the four quadrants and why the second and the fourth quadrants are not preferable for making the engineering drawings, and how the first quadrant and third quadrant are going to have the front views and the top views recorded in the vertical and the horizontal plane in a distinctive manner, and why they are preferred over the second and fourth quadrant for making the engineering drawings. Thank you all for watching the video.